Yes, let's start. So we have Isaac today. So he's a top, I would say this, he's one of the top experts on F Sharp community. And yeah, if you don't know him, he has written this book that now, yeah, that it's, yeah, I would say a must read. If you are in F Sharp, there are a few good books, so that's one of the best that you can get. Right? So I strongly recommend that if you start your F Sharp journey, you go here. So yeah, we are really lucky to host him. So really thank you to come to our meetup, and we will have presentation, and then we will have some time for questions and answers. So please just post it in YouTube or in Zoom your questions, and we can have a chat after the presentation. So yeah, all yours, Isaac.
Brilliant. Thanks, Pal, for that lovely introduction and doing some sales for me on my book. That's always well received. Thank you.
I just read it. It's really great. Yeah, it's really great. I mean, there are not too many books in F Sharp, so that's yeah. Honestly, it's really good. So yeah, good job, man.
Thank you. Got another person waiting. Let's let them in. There we go. Right. So yeah, thank you everyone for coming. Obviously, whether you're on Zoom or YouTube. Thanks, Pal and David for inviting and organising this. It's always strange with the whole coronavirus sort of not being able to do user groups in person. So yeah, something I'm still sort of getting used to. I've done a few of them now online. I think as long as a few of you have got your video open, then that's good enough for me. So yeah, David, Pal, Cesar, thank you. Leave them on. That's perfect. Then it doesn't feel like I'm just talking to myself for an hour. Good. So yeah. So the title of this talk was originally like "Go Pro with F Sharp," and I renamed it today to just F Sharp Just Start, because I was worried that people would see this kind of "Go Pro with F Sharp" and think, oh, that must mean that Isaac thinks C# and VB.NET is for amateurs or somehow negative or bad. And I really wanted to avoid that. And also that title was made almost like 18 months ago, 2 years ago, and I've sort of been modifying and evolving this slide deck and the content over that time. And it's more about now, I think, that F Sharp is in a place now where there really is, it's easier than ever to get started. And it's a really, really good time now to start looking at it. Particularly because of the steps that .NET have made in the last few years, and also C#. And I think what we'll talk about today is not really just F#, but it's the whole ecosystem. And I'm hopeful that this will be more of a discussion where you can, ask questions in YouTube and Zoom, and rather than waiting until right at the end, if you've got some questions throughout, then just ask. And worst case, I'll say, yeah, I'm going to come to that in a minute, or it's a good time and I'll explain it then. So please do ask. There'll be probably 45 minutes, maybe even an hour of me just going through talking and slides and stuff. And then there'll be time afterwards for a couple of demos and yeah, and some coding and so on. So let's sort of start with that then. Yeah, just in case you don't know me, obviously Pal's already introduced me, but yeah, I'm Isaac Abraham. So yeah, that's me. Briefly, I've been using C# since .NET 1.0, so that's like almost 20 years now, which I'm actually shocked when I say that, but it's been around for almost 20 years now, C#, which is great. I've been using F# for a bit less than that, probably 5 years maybe. Obviously, as you can tell from my accent, I'm not German, I'm English. I grew up in London, but I live in Germany now. I've been here for a few years. I'm the founder of CIT, so we're a company that do F# and Azure consultancy, development, and training solutions. And I've almost got to say that I'm a Microsoft MVP. I don't know what the title is anymore. It used to be F#, then it was .NET, now it's developer or something. I don't know really, but yeah, that's pretty much it. So the real question is, why am I giving this talk? What am I trying to achieve from it? What is different from all the other talks out there that are really focusing on F# and often for the same sort of audience, F# for the C# person. So I want to just explain my motivation behind using F# in the first place, just in case, just to clarify really why I use it, and really what is important to me as a developer. So for me, the most important thing is writing software that works, that does the right thing, is high quality. It's not about F# per se. It's about doing something that our customers find valuable, that it's useful, it does the right thing. As part of that, I think the best place to write high quality software is on .NET, particularly on .NET Core, which is really, it's in a really good place now. In the last 2 years, it's made huge leaps, and it's really gone forward, and it's in a really, really great place now with .NET 5 just launched. And then after that, if you are running on .NET, I think that F# is the best place to do that. So it's top down. It's not that I'm writing F# because I love F# and the fact that I'm running on .NET and I'm writing quality software is a side effect or a byproduct. It's almost the other way around. So for all the things I'm going through today, please just keep that in mind. I'm not doing this because I'm passionate about F# because it helps me do good stuff for our customers, not the other way around, if you will. So a lot of the other talks out there, they basically start and for almost a bottom-up point of view. Many of the talks that you'll see on YouTube will look at different language features of F#, and they'll talk about records and active patterns and all these things on the screen that either weren't in or still aren't in C#. And they will highlight, okay, question from David. Yes and no. We'll come to that towards the end of the slide, but I'll talk about real world experience because the question is basically F# is interesting, but I think there's not a great deal of demand out there. What's your opinion? So we'll come to that towards the end of the slide, but great question, David. It's a good one, and we deal with that all the time. So yeah, a lot of the time we look at these kind of features in isolation. They look interesting, but they don't really give people a feel for what F# is like to work with as a developer. So it often ends up just confusion. And I've done talks like this where I've gone through all these cool features, but people have left sort of impressed with it, but not really understanding how do I start using it tomorrow, or what is it going to give. So this is really what I would answer that with. The truth is I can show you all these language features, but you probably won't end up knowing or really grokking what is F#. And it's not about really going through these features one by one and adding them on top of each other to come up with this sort of, yes, F# is great because it has all these things. It's this unique blend of features and the different way it's tweaked and the different knobs that are turned and tuned to really give it this really nice expressive language. And also, I would say just as important is what features F# doesn't have and what things you can't do in it, which really push you down the way of doing things in a certain way. So that's really what I'm going to talk about, almost not exclusively, but part of this will be about how F# makes you feel as a developer, what the experience is like, as opposed to looking at all these low-level language features. And I'll probably talk for maybe 20 or 30 minutes about that kind of thing, and then we'll look at some code samples and some demos as well. I usually ask this when I do this talk, but I'm assuming that most of you are people from a .NET background who maybe have heard of F#. Maybe some of you have done a little bit of it, but I'm assuming the majority of you are coming from a background of C# and maybe Visual Basic .NET, and are interested in learning a bit more about F#. I don't think Zoom can let you do polls so easily, so I'm just going to assume that, and yeah. So the three things I'm really going to talk about is to define what F# is and it isn't, why you should be looking at it, so the value proposition behind it, and then towards the end of the slides, and the talk will be a bit more about how you can get started. So I'm actually going to start with a very quick demo. And let's just open this up, save search. So David, is that showing up or Powell? Is that showing up there? Safe search or not? Yep. Great. Okay. You never know when you're sharing screens. Sometimes things show.
Yeah. No, it's good. We are watching. No.
Yeah. Great. Good.
Well, sure that it's good.
So this is a web app that basically I did a couple of years ago now. So it's actually showing its age a little bit. And it's basically about UK house prices. In the UK, everyone is obsessed by the property prices. And if things are going up, then everyone's happy. And if they're going down, then it's a disaster sort of thing. So what this app does is it basically imports data from a number of government websites that basically show like price data and geolocation information, puts it into Azure Storage, puts it into Azure Search, hosts it on a website and does stuff. So I can sort of do some searching here. So I can say, I want to search for Tottenham. I get sort of find as you type. I can click search. I get these results that are being sourced then from Azure Search. We get things like faceting search. So I can click on these to filter down the results, kind of like what you get in Amazon when you see sort of sub-selects. You can do the usual sort of sorting. We get things like Google Maps integration and so on and so forth. I can drag around, pop-ups, all the sorts of things you would expect in a kind of a modern sort of SPA application. We even do kind of, overlays, so I can see a map with different prices and tooltips and so on. The actual application itself is not sort of so interesting in terms of the domain. It's more the fact that it's a web app. And the real thing I always do when I start with this and sort of demonstrate that, and even little things, I'll just actually go back and just show things like if I'm searching in here and I put in an invalid postcode, as I'm typing, we're getting sort of real-time validation on the client. So the question I always ask is, when I'm showing this demo, is how much of what I just showed you is F#? And I normally ask things like, hands up if you think it's 25%, 50%, 75%, or 100%. And most people say 50% is probably the most common answer I get. Some people say 25% even. The answer is actually 90% of that code base was all in F#. The only bit of JavaScript is a Webpack file. And any of you that have done Webpack will probably be able to understand this number is basically one file and it accounts for 7% of the whole code base. Either that's a sign of how verbose Webpack can be, or how terse and concise F# can be, or maybe a combination of both. And I think the 1% is, I think, one HTML file and a CSS link, so not really much else. The idea there is really just to dispel this myth that F# is for like scripts and crazy applications. You can write, and we do write on a daily basis, web applications using all the normal technologies that you use, whether that's SQL, Azure services, ASP.NET, console applications, WPF apps, all of that. So yeah. So a question from Alberto was, for the end of the talk, are you going to update your book with F#5? I can answer that now. Yes, I will. It's not happening right now, but that is one of my intentions at some point. Happy to tell you more about the backstory of that later on. So what is F#? I'm just going to spend a few minutes defining it now and then kind of going from there. So in a nutshell, F# is a general purpose language that you can write applications on, runs on .NET Core, and it can interrupt with C# and VB. It's a strongly typed language. It's got a compiler. It's statically typed. It's got a very lightweight syntax, and it's functional first. By that, I mean, it leads you down the route of writing code that sort of have functional programming characteristics in it, but it doesn't force you to do that because it runs on the .NET BCL. It has to anyway support things like classes and methods and all those sorts of things and inheritance. It just doesn't really gear you up to writing your own code like that, although you can if you want. So I guess the best thing to define next is really what is functional programming. When I say functional first, what do I mean by that? Normally the sorts of things I see are people saying lambda expressions is functional programming, pattern matching, all these kind of things that I'm showing here. But really lambda expressions have been baked in to .NET and C# in a sense from C#1 because you had delegates in C#1, and then you had anonymous methods, and then you had Lambda expressions, but they basically allow you to pass functions around code. Pattern matching, yes, maybe. Non-nullability to me is something that's common in some functional languages, but it's not really a trait of functional programming. Composability, yes, but you can also compose stuff in OO. You can use inheritance and traits and things like that. To me, the real fundamentals of functional programming, at least in .NET and F#, is really two things: expressions and immutability. And for those of you that don't know what they are or aren't sure, so expressions is basically the notion that everything has a result. That's really all it is. There's no void. Everything you do has some kind of output, some kind of return type and value. Immutability is the idea that there is no variable. There are simply values. You create values, and that's their value for life. You can't change them. And that has some really nice properties in the sense that you can create values, you can chuck them around your code base, and no one can change them. You can't pass a value to another function or a method and something gets changed without you realizing about it. So it simplifies many things. It enables parallelization as well. But generally, it just basically simplifies things. The important thing is with F#, these two are kind of core things in the language. They're really deeply part of the language in a way that for C# it simply isn't the case. And whether that's a good thing or a bad thing depends on your perspective, and that's what we'll talk about later on as well. Why would you want to do F#? I've sort of explained what it is at a high level. We'll see some more things in it later on, but why would you want to do it? And this was a story for F# in 2005, was solve complex problems with simple code, which is true. The problem with that was people thought that this meant that F# is only designed for complex problems. It's only useful for that really hard problem. I would say now in 2020, the answer is really solve simple problems with really simple code. It's not about only for hard things. And I sometimes see people sort of thinking about this in the sense that you can't have both. You can't have a language that is simple, that can do simple problems with simple code and complex problems with simple code, but you can. F# can do that. And I think it's a little bit lazy from some people that kind of assume that sometimes, but it really isn't the case. I'm certainly not some kind of Haskell background. I'm a C# dev. We just write line of business apps most of the time. F# makes that really easy to do. So simple as that. So that's kind of dispelling one of the myths, but that's how I would think of F# today. The sales pitch as a developer or someone thinking of investing in F# in their team, why would you do it? Well, one, the most obvious thing is it lowers your development cost. Things are quicker to develop, you get fewer bugs, it's easier to maintain a code base once it's gone live. It's generally just a lower total cost of ownership. The other thing is developers tend to be happier. And this is kind of more the emotional side. Because you're more productive, you feel like you're more empowered. You're doing more work. You've got more confidence that what you've written is the right thing. And to us, whenever I'm interviewing devs, these are kind of the questions I ask. Why are you interested in F# if you've been doing it? And they almost all of them will tell me this. I enjoy F# because it makes me more productive. I'm not scared of writing code without unit tests, or I'm not scared when I release code now because basically it works nearly all the time. Obviously, we still have bugs, but it's much greater chance that you'll get it right first time. It also opens the door to a few new areas of F#, in .NET. Whereas I think sometimes we think of .NET as being a language for, SQL, web apps sort of thing. But F# opens the doors to more data-oriented things, scripting, analytics, things that you may not have considered doing before in .NET. And it also enables us to work a bit closer with our customers in the sense that you can actually open up some code and sit with your customers sometimes and actually do some modeling. And they will actually be able to understand what the code says, particularly around the domain modeling area. Okay. So I would say F# leads to the pit of success. What does this mean? I think for those of you that have been in teams where you've led projects, we've all been in the situation where you've written some code, explained to the rest of the team, this is how you write your code, this is the patterns we're using. You've gone on holiday and then come back a week later and everything is destroyed. All of the team have ignored all your patterns, they've done the wrong thing, but they didn't know they were doing the wrong thing. That's what this diagram is kind of showing. This Mark Seaman came up with this. I think it's a really nice picture. It basically shows that if you imagine your code, the red sort of circle at the top is essentially where things are right. And it's so easy to just push it a tiny bit one way or the other, and it goes into this sort of the areas on the left or the right where things go wrong. So here and here. F# is the other way around. It's hard to once you've got a code base with a pattern in place, it's easy for developers often to follow that pattern, to do things in the right way, rather than you continually having to tell them or put comments in that saying, never do this. You can usually encode those kind of rules in the type system, in the code base. So it's kind of easier for people to see the obvious path. This goes back to my original slide, which is F#, I think, is now in a great spot for .NET. This again, why should I use F#? If we think back maybe even just 3 or 4 years ago, this is what we tended to see with a lot of kind of applications and libraries and frameworks in .NET. Everything was about code gen. You know, you've got a designer first, like entity framework, file new project, closed source, you know, all these things made it difficult for F# to really be on a kind of the level playing field with C#, because Visual Studio had code gen for C#, but none for F#. So F# kind of took a very different approach, which ironically is where a lot of .NET now is. Everything was code first from the start. There was always CLI tooling. APIs were designed so that you didn't need to generate code, but rather the APIs were written in such a way that it just did the right thing anyway. Things were open source by default. So if you think of C# has now made this transition in terms of .NET in the community, F# is now in that position anyway. So this is kind of a nice way where if you're using C# today and you're already using .NET Core, many of these kind of things will feel natural in the F# world anyway, because we've always been doing this. And the last point I'd say is Microsoft and the community. So if you're concerned about Microsoft, they are firmly committed to F#. They're increasing the team size. I think it's 5 strong now on the compiler team. They've got devs in Prague as well as America now. They're undoubtedly what I would say a key player in the ecosystem. So they're an important part of F#, but they're not the only person that's contributing software to the F# ecosystem and the community. So there's obviously a kind of a deep grassroots sort of set of developers that are writing libraries that F# use, and Microsoft are a key part of that, but they're not the only player there. And that's, I would be really happy if .NET in general got to that point as well. I think some libraries there are, but I'd love to see more of that happening in the future. Okay, so this part, before I begin the next part, I would just say this is not a rant or anti-C#. This is not me having a go at C#. I myself am a C# developer. Everything I say for the next section, take through the focus or the understanding that I'm someone who's used both C# and F#, and these are my observations and my opinions over the time. So this is basically some of the fear and the uncertainty I see about F#, and I'm just trying to remove that really. And hopefully with a bit of a joke along the way. So one thing is F# is a general purpose language, which I already said. So when someone asks you, or if you're yourself asking yourself, I'd love to use F#, but I just haven't got that problem that's hard enough to really justify using F#. I hear this all the time. You know, I'm just looking for that area where it really shines. The answer to that is basically the area F# shines is programming. So if you are doing programming, F# is a great language. You don't have to wait for that, you know, that mathematical machine learning or crazy algorithm stuff. F# is just great at getting stuff done. And that's really part of the mentality, I think, is really it's about getting stuff done. Some other myths I hear, it's too hard, It's only for maths and science. It can't be used for the real world with apps like web apps. And it's not designed for line of business or enterprise software. I can tell you firsthand that's all nonsense, because we are doing that right now for customers. We're writing web apps exclusively in F#, end to end. So there's no reason why you can't do it. It's more about whether you want to do that or not. This is often the biggest challenge I see people coming to the F# world from an OO background. It's the challenge of moving and forgetting many of the lessons that you've learned in the past, rather than F# being inherently difficult. And that's really really what this is about. F# is not hard. F# is different to what you will already know. And that's really the challenge that you're going to face if you learn F#, is almost removing some of the assumptions that you already have as potentially a long-time software developer, and just starting with a clean slate almost, and trying to remove some of the assumptions that we have. If you can do that, I'd say that's probably 75% of the difficulty of around F# removed. I think at this point, probably worth spending a bit of time just talking about C# and just acknowledging what it is, which is a great language. I would say it's the best OO sort of centric language out there. It's got loads of features. In fact, I'd say it's got more features than, well, it's definitely got more features than F# now. It's got amazing tooling, large user base, you know, it's rapidly growing and iterating after a kind of a couple of years of relative, I wouldn't say stagnation, but at a slower pace. Certainly since C#7, it's getting lots and lots of features now again. Just a few tweets that I sort of highlighted. So from John Skeet, who's kind of one of the daddies of C#, in a sense. You know, C#8 came out talking about replacing a lot of code with things like nullability and switch expressions. Other things like 3 features in C#8 that will change the way you write code. These are big changes happening in C# these days. C#9 is the same. These are not sort of value add small features like, you know, string interpolation. These are things that are actually changing the nature of C#. And you'll see that if you look on Twitter right now, people talking about pattern matching and records. Lots of debate about the best way to write code, back and forwards, really. And where is C# really heading then? If you look at a lot of the features coming into the language over time, but particularly in the more recent releases, 7, 8, and 9, a lot of them are coming from functional programming languages, or at least languages that tend to have these features. So tuples, pattern matching, local functions, all of those were things in F#. Switch expressions is basically pattern matching. Again, nullable reference types, records, all of these are features that you'll see in ML languages or in other sort of FP languages as well. So I think there's kind of a clear sort of shift towards introducing these features into the language. But at the same time, if we think again what I said about hard and different, people are looking at things like records now and saying, oh, or pattern matching, saying this is really hard. I would say it's not necessarily hard, but it is different. These are kind of features that I ask often when I'm doing this talk, and no one knows the answers to these things. So if I say, what is this range 1 to 3 return from this array? Which letters would you expect to see? 9 times out of 10, I will see things like either B to D, or A to C, or A to D. The answer is actually B to C, because it starts from 0 based, so 1 goes to B. But on the upper bounds, it's exclusive. So it's essentially 0, 1, 2, 3, but then back there. So you get B to C. Does this mean C# is hard if you didn't get that right? Or maybe just you've never seen this before? You know, what does the range hat3 to hat0 give you? I can't even remember this one. It's Hij, so it's the last 3 elements. 5, 5 gives you back nothing, because it's the 5th element to the 5th element exclusively, so you get nothing. if you didn't know what this operator means, this is called the null coalesce assignment. So it basically takes obj.keys. If it's null, it will replace it with this. If it's not null, it will do nothing. Again, whenever I give this talk, I see a lot of confused faces from people that are C# devs. They've just never seen this before. This was a code sample that I don't know if it was from the official sort of .NET or C# team, but I saw this as when C# 8 came out to try and show all the features that C# 8 had. This is not easy code to read if you've not done pattern matching before, if you don't know what async await is, or if you don't know what nullable reference types are, or if you don't know what deconstruction is, where you can go from a customer to a tuple within a pattern match. This might seem very, very weird. Doesn't necessarily mean that C# is difficult, but it is different to what we maybe know in the past. Just to really drill that home, I've taken this from a set of tweets I've seen recently, which is how do I test for string null or empty in C# 9? And there's like 7 ways to do this now. So like the first one that you probably all know is null or empty. And then there's like a whole range of various different ways. So nullable check dot length is more than 0. Pattern match here where curly brace means not null and then has a property of length which is more than 0. Checking if it's null or string with all being a pattern match and then negating it all. Crazy operator stuff, more pattern matching stuff, and then switch expression. It's like there's lots of different ways now to do things, and this is kind of a challenge that C# faces, I think, which is what is going to be idiomatic code in C# tomorrow? And I don't really want to spend too much time talking about that, but just think about, you've got this kind of functional stuff coming in now with pattern matching and stuff like this. And then you've got the old way of doing it, which would have been if-then statements, switch, string is null or empty, and so on. And I actually wonder what C# is going to look like for a new developer tomorrow. What would they consider the right way to write code? Here's another one. This was actually taken from some code in, I think it was in the ASP.NET code base, where I think even someone remarked on the team and said, oh, this is quite cool code. It's got all these different operators. This is really F#y code. This is not F# code. This is not what F# is about, if you see this. You've got, okay, a lambda here, then you've got the null Elvis thing, then what is that? Null coalesce, not equals to, ternary operator. I can't look at this code and know what it does. So if anyone shows you this and says, oh, this is the sort of code F# is about, then that's not it. It's not what it's about. People looking at the default interface members in C# 8, and it's sort of like Jeremy Bytes' blog, the Jeremy Bytes blog. Jeremy's a long-time C# dev. He knows his way around the language. If someone like him is lost, then these are new things. These are big changes in the language, and this is almost some of the issues that you see, not necessarily with default interface members, but when you bring in almost an entirely separate way of doing things alongside an existing pattern. Now, I hope you'll indulge me when I say that the next few slides, it's basically something that a lot of F# developers will see, which is, for years we've been talking about F# is great. It's got all these features like pattern matching, records, local functions and stuff like this. And the response was basically, yeah, but I don't need it in my day-to-day job. Or, yeah, but it's not really useful for real-world programming. And today we see the complete opposite, where you'll see things like F# pattern matching, no. C# switch expressions, great stuff. Or F# records don't need C# records, brilliant, Or local functions, lightweight use syntax, F# lightweight syntax. This one is actually an interesting one. For years I heard things like people say that the lightweight nature of F# meant it was really difficult to read. My gut feel was this was just about different than hard and difficult. And now that we've got C# with a lot more operators, which I actually think are quite tricky, people are getting quite excited about them. So maybe a lot of these kind of preconceptions we may have thought about F# aren't actually true anymore. just as an example, to create a list in F# is basically just square brackets. Pretty easy to do. In F#, in C# you have to do the whole generic list thing. Other ones, you don't need return in F#. You just don't need it. It's built into the language. Don't need semicolons. That's just not needed either. So a few of these kind of things. The last one is actually interesting, which is basically about operators. And I actually think now that F# it really doesn't have many operators. I don't know really where it got that reputation for being operator heavy. C# has got a lot of operators now. So, F# doesn't have null coalesce. It doesn't have the assignment one, the Elvis, ternary, nullable, null override. None of those exist in F#. It's basically just language. It's just a couple of simple operators and library features. That's the rest of it. So once you've learned them, it's really just variations on a theme. The only one you have in F# that you won't have in C# is this pipeline operator, which is that guy there. And I'll just show you what it does if you've never seen it before. And it's actually really become popular. So it's now actually, I think it's even coming into JavaScript, and other languages are getting this as well. So all it does, it's really, really simple, but it's really powerful, is if we've got a function add 5 and 10, we can switch it around and say 10 add 5. So 10 goes into add 5. And why is that so useful? Well, if you imagine code like this, where you have this kind of nested explosion of methods that are chained on one another, and we've all seen code like this before. Well, with the pipeline, you can switch it around, and then it just becomes easy to read. Yeah, 10 add 5 goes to multiply 2, goes to add 3. Easy. And of course, you don't have to use that just with numbers. You can use that with anything you want. So the best way I think of this is any function in F# is implicitly an extension method, or the equivalent of an extension method in C#. So we can take any function and pipe it into another function arbitrarily, which is very nice. Just to prove to you that when I say hard and difficult, the stuff I find hard, I don't find F# hard. Things I do find hard are things like SharePoint. If there is someone on this call that is doing SharePoint today, please let me know. Like, I don't even know how to find a subsite from our main site, SharePoint site. I will pay good money for someone to show us how to use it. I really find that difficult. I find JavaScript difficult. You've got this whole sort of equals, and then you've got the double equals, and then you've got the triple equals, and they all mean different things. That I find difficult. German grammar I find difficult. There's at least one Austrian on the call, and maybe others on YouTube. An interesting sort of parallel would be, for me, when I first started learning German grammar, or German in general, I found it very difficult. But if I'd have turned around and said, German is very difficult, it has all these concepts that English doesn't have, therefore German is not a real world language for speaking. Yeah, that probably says a lot more about me than it does about German. Or if I'd have said, German is a really hard language, anyone that speaks it must be an absolute genius. Yeah, then again, that might say more about my preconceptions of German and more about English, that English actually is a really simple language and it doesn't have many complex grammar rules, than it does about German. So think of it in that regard. .NET versioning is probably the last one. I have no idea how this works, how you can have an SDK that the version upgrades, but yet the SDK release number downgrades. I don't understand that. So maybe one day, Imo, you can explain that to me. I'll never figure it out. Anyway, just to round off this section, I'll just give you some common reasons I do hear from people as to why they don't want to look at F#, given all of this, and just the common answers I give. So the one thing I hear is, I don't understand the benefits it offers. Totally fine, but that's simply a knowledge gap. So there are plenty of great resources today that we didn't have 5 years ago. There are books, there are YouTube videos. Kit Eason has just released on Udemy a video series for F# now. So there really are good resources where you can learn what it's about, and talks like this, of course. I don't have the time to learn it. I would reframe that when you say that to, it's not important enough for me to prioritize up the list of things to do. We all have too much of, to do. There's never enough time to do things. This is more a question of how important it is to you. Is it a strategic aim for your team and your company or not? And if it's not, that's fine. That's really what the decision is. There's other things that are more important to you than F#, which is totally fine. But I think that's the way to frame it. It's simply that you can't prioritize it. Your company don't allow it. I hear this often. The reality is that I see actually companies actually able to adopt it as long as you frame it in the right way and are able to justify it and show that you're putting a reasoned case study together for it. There's a blog series on our company site that gives you 3 posts as to how to frame it. So if you do want to talk to start using F# with your boss, doesn't allow it, some ways that you can actually get it over the line. The tooling is not as good as C#. This is totally true. C# has got tooling that is better than any other language. No other language competes with C# in my opinion, particularly if you add on things like Rider. That doesn't mean that F# tooling is bad. In fact, if you compare it to many other functional languages, F#'s tooling is probably better than all of them. Plus, the nature of F# as a language means that you tend not to need to require as many of the refactorings that you have in C#. So it's not a kind of an either or in that regard. I don't like the syntax. Yeah, that could be the case. You don't like the idea of not having return or not having semicolon or whatever. Totally fine. I suspect though that if your reason for, if you acknowledge or said, yeah, F# is more productive than whatever language I'm working in today, but I don't like the idea of not having semicolons, your boss or your customers may not agree with you in that regard. This is the last one that I will actually agree with, and I see actually quite often, in the sense that F# can be difficult, as I said to you before, to get up and running with, and to really change your mindset about modeling and writing code. So I've seen people that are really, really great developers, way smarter than me, and they just can't get F# because they've been writing code for a long time in a certain way, and it's very difficult to lose that kind of that way of thinking. I've seen that. I've worked with people that have really struggled with it, and I can totally understand that. And that's really what you need to answer yourself is, are you someone that is going to actually find F# more natural fit for you, or going against the grain for how you go about solving problems? Last question I'll point on this area before I move on to the next section is, why would I bother using F# at all? In the sense that C# is getting more and more features. We know this. It's now got records. Probably C#10 will have some form of union types. It's already got pattern matching. It's already got tuples. Things that we used to look at F# and say, look at all these things F# has got. C# hasn't got it. This is not to me, that's not really the thing that we should talk about, actually. When someone says, why shouldn't I just wait until C# gets everything from F#, that's not how you should be thinking about it. It's not about adding features one on top of another and just saying this language has the most features, it's therefore the best. If that was the case, then everyone would be using Scala or Haskell, because that's, they've got the most powerful languages. They've got more features than everything. So it's clearly not about that. The way I tend to compare the two is C# is essentially a way that it started off as an OO language, and it's added in FP style features that have kind of blended in to create, in a sense, similar to how Scala is. It's not quite the same, but the idea that it's a blend of FP and OO in one. The way I talk about F# is a kind of much clearer separation, where you have two halves to the language, where you've got FP side and the OO side, rather than one contiguous language. And you can write applications that use just the FP features or just the OO features. Or you can use languages that use a mixture of both. And I tend to see people writing apps nowadays in F# that are probably 90% FP and maybe 10% object features, something like that, maybe 15, 20%. But generally it tends to be that, rather than with C# you have this kind of mixture that's come as one. The best way to think of this in terms of why can't I just continue to add features? Why can't we just do that? Is twofold. The best way of thinking of it is, imagine that you are in a restaurant and you've got a menu. You can pick any dish from that menu and it has no impact on the other dishes on the menu. You know, you can order ice cream and it doesn't change how the pot roast is going to be. That's not how programming languages work, though. You can't continually add on top of another. It's more like ingredients on in a recipe, where some ingredients you can't mix with other ones. You know, I couldn't say, well, I like ice cream and I like pizza and I like honey. I'm going to mix them all together and it's going to be even better because I'm adding them all together and I like ice cream and I like pizza. So mixing the two is going to be better than each of them on their own. It doesn't work that way. Some ingredients actively work against other ones. And that's really what I would say about why not just wait until C# gets everything, because there are some features that C# has that actively work against other features that are coming into the language and limit the effectiveness of them. And that's what we'll probably see in a minute. When I talked about OO characteristics and FP characteristics, and I said that the challenge for you is which side of this kind of fence are you on? This is probably the one slide, if there is one slide that you take away from these 50 or 80 slides I'm going through, this is the one that you should really take away. This is the one that you should remember. If you write code that likes these things on the left, you like writing code that's statement oriented with side effects, void methods everywhere, mutation, imperative code, inheritance, you are basically saying you like OO characteristics. That's totally fine. That's the way you work. If on the other hand, you are writing code that is more about, give me some data and I will give you a result. I'm excited by records, for example, if that's what you're saying. If you're excited by pattern matching, where it basically says you're going to separate data and behaviors. If you like link and the declarative nature of it, those sorts of things, then you will probably find F# a nicer fit for you, because these features are baked into the language as first-class citizens. So C# makes it easy to do things on the left. F# makes it easy to do things on the right. And as much as people would like to think, you cannot have one language, in my opinion, that takes both of these things and makes them equally easy to do. You can't have it. You can't have a language that says things are mutable by default and immutable by default. The things are opposite. So ultimately, you have a decision to make: is how do you like writing code? How do you like modeling things? How do you like reasoning about things? And making a decision based on that, which language suits you better. It's not about which one is better or worse, it's which one is better or worse for you. And just as an example, excuse me, here are some things that you wouldn't do with F#, just to give you a sort of a flavor of the things I'm talking about when I say there are some things on the left that sort of block against the ones on the right and vice versa. So all of these things are things that either are impossible or difficult to do in F#. There is no such thing as void in the language. You can't do early returns, really. Mutation means putting extra keywords in. There is no protected. You can consume classes and inherit from them, but you can't make your own protected fields. There's no implicit conversions. You can't create half of an object. These are things that literally are either impossible or difficult to do. You can't even do cyclical references. So in F#, you can only reference things that have already been declared, both inside the file and inside the project. Now that gives certain benefits. Also means that you can't easily do things that you might take for granted in C#. I would say F# encourages what we call now object-based rather than object-oriented programming. So things like creating objects and classes is okay if they're immutable. You can use interfaces, we use dot notation, so properties and methods. That's fine. That's not a problem. You wouldn't tend to use mutable data much. You use it in corner cases, casts, overloading, things like that. These are all, you would only use them, I think, once you know how to use them tastefully. Don't just use them all the time. And then you'll have things like inheritance and nulls, which are like, don't go near these. If you're using these, you'll be happier in C#. The closer you go to the right, stay with C# because F# incurs costs for you as a developer to use these things. If you stay on the left, you're probably fine. And this really goes back to what I said before about some features actively work against others. So F# has really, really good type inference, as I'll show you later on. But features like implicit conversions or cyclical references kind of work against that, or method overloading. So if you have features on the left, it somehow weakens the things you can do on the right, which is why some things, if you look at C#'s type inference, it's pretty basic. You basically just have var on the left-hand side. With F#, because it doesn't have these things, it basically says that we can take type inference up like 5 levels, and we can infer basically everything in an application. You can write entire apps without having to often put any type hints, as input arguments, as return types, as anything. So these are the kinds of trade-offs that you make in a language. And the real point, again, is you can't just add features in. You just cannot continue to add them. Every feature has a cost because you have to get them to play nicely with every other feature in the language. You can't make breaking changes in C#. You can't make them in F#. And it has to fit in the overall, how shall I put it? The shape of the language or the feel of the language. So it's difficult to do. And the last part I would say on this is how would F# change how I code? One is this notion of trusting the compiler. The compiler in F# is more of, I see it as rather than my enemy that I need to beat, it's my friend that lets me write things the right way. It helps me to know when I'm doing something wrong, something stupid. And I do stupid things a lot. So I like the F# compiler because it stops me being stupid. You tend to focus, in my experience, on smaller pieces of functionality. When I was writing stuff in C#, the way I would tend to start was very much from a top-down point of view. I would think about design patterns. I would think about where I'm going to orchestrate my code, how I compose the big pieces together. With F#, I tend to usually go the other way around. I'll start from bits of small functionality, just single functions. I'll explore them, I'll play around with them, make sure I'm happy, and then later on I'll plug them together. But I won't tend to do that upfront, which means that often you can come up with some relatively simple solutions relatively quickly. Without really wasting time, frankly, on coming up with 20 different design patterns and not really needing them. You also have this notion of separating data and behavior, which I've touched upon. So rather than having classes with methods, you'll tend to have records and functions. And a function will take in a record and give back another one. It's basically it. It's a really simple pattern, but it really does work. And this is the one that confuses people a lot. Particularly when they start out with F#, is you spend a lot more time coding proportionally to what you do overall, but you will spend way less time debugging because you'll spend more time with the compiler warning you or telling you, you've done this wrongly, you need to do this, you'll fix it, and then by the time you run the app, it tends to just work. So that's a kind of a mental shift where you might find that a bit disconcerting at first, but it tends to be much more satisfying. Okay. Okay, before I jump on, let's just see if there's any other questions. I mentioned domain model areas. Do you apply DDD made functional? I'm not sure what the question is there, Alberto. Was the question there, did I write or have I read? Or can you do DDD in a functional style? Yes, so we do some, I wouldn't say that I'm a kind of a massive DDD expert, but certainly we're seeing people use it. I mean, Scott Volashin's book, the DDD Made Functional, is a great example of how to adopt it. And it's, again, it's really the things I've mentioned already, and I'll show you later on. It's basically records, union types, and functions. And those things really help. Scott's book is very, it's a really good place to start. You can see how F# is applied from a modeling point of view, and it really does make sense. So yeah, I definitely recommend that book. Even if you've not done F#, just to almost show you how you can do things with very simple rules and very simple types. Right, good. I'm going to just speed up a little bit just to keep to time, because I'm aware it's already 7:30. Paul, David, half hour, 45 minutes more. Is that all right? Or
Yeah, you have time. It's up to you. So you don't have to speed up. Don't worry. Yeah.
Okay, fine. Yeah. Good, thank you. I just don't want to keep people. Yeah. Anyway, okay, good.
I think it's really interesting. So yeah, go ahead.
Okay, cool. Okay, I'll keep going. So why are expressions important? I touched on these almost right at the start of the slides. Expressions and immutability. Oftentimes, particularly in the C# world, expressions aren't really, it's not really clear what they are and aren't, because in C# rather, you can almost mix and match statements and expressions. Whereas in F#, it's very, very clear the distinction between the two. Expressions are super important because they let you reason about code more easily. And importantly, they let the compiler reason about code more easily. By that, I mean, the compiler can help you more than with statements, which is what we tend to use in C#. Expressions are much clearer, and the compiler can tell us when we're doing things wrongly, which means less chance of bugs, less chance of Isaac being stupid, which is always a goal. And the succinct code bit is kind of a byproduct, but you'll see that with things like switch case statements versus expressions. You can see that today. This is an example I've had for years, and it's still valid today. This is what should be a relatively simple bit of code, which basically says, given an age, print out a greeting of, hello, you are a child or an adult, sort of thing. And there are two deliberate bugs in here that usually I ask people if they can see it. If anyone is interested in just chipping in and saying if they can see anything, then please do. I'll give you maybe just 10 seconds and then I'll go through it. And feel free, if you're in the channel, to just unmute yourself and speak. You don't have to type.
There's something, it's not covering all the cases, right? The if else here.
Yep.
That something could be null, or I don't know, integrity.
Yep. So if someone is older than 64, then we will just basically use this description at the top. So hello, you are a nothing. Not very nice. Not very polite for those in that generation. So that's one bug, absolutely. There is another one, which is that we've basically used the wrong variable here. I've bound to the wrong one accidentally. Did age description here, but I did greeting down here. And the compiler can't help me here. It has no way of knowing what I'm trying to do. It just knows I've got this arbitrary if block here. And I've said, if this, then do this, else do that. But it has no idea that what I'm really trying to say is both of these should modify the same variable. You can fix this in C# by basically changing this code to be an expression. So I can write a function here called getText, and that function takes in the age and returns the text, and call that down here. And if you do that, that simplifies everything. You don't need this kind of default value at the top with nothing. Age description is now immutable. Beforehand, we were setting it to a value and then changing it down here. Now it's become an immutable value. And here, we can't remove the else. If we do, the compiler will tell us you can't do that. You must return something from each side, from each branch. You must always give a string back. In F#, this is how we would normally write code. But in F#, if is actually an expression. So you can literally do that whole thing in line, because we say if age is less than 18, then child, blah, blah, blah. If you miss out a branch, the compiler will give you an error and it will tell you must always fill in the branches. If you gave an int back here, then it will tell you can't do that. They must be the same. And you can't assign it to the wrong field because it's all done as one atomic action. So if you imagine that, this is a really simple example, but now expand that across your entire code base, that kind of mentality really adds up and really starts to make savings in terms of accidental bugs. Question, what is a debugger, from YouTube? So a debugger is basically a tool that comes with many development languages and tools like C# and F#, where you can run an application and pause it while it's running to examine the state of it. So a common pattern in many languages is I will write some code, make sure it compiles, and then I will run the application and I will see if it does the right thing. Now that might work, but it could be very inefficient. Imagine that to test your code, you needed to click through 17 screens and fill in 3 forms in the application to get to your code. Then you realize you've made a mistake, change it, run it, go through the same steps again and again. That's not a particularly effective way or efficient way of writing, of developing, I think. And there are better ways to do that. One is to actually have the language tell you up front when you're making mistakes, rather than having to run the tool to find those mistakes. Another one here from C# now. So this was the old way of switch case statement, and you've now got the switch expression. It's the same thing, except you don't have this assignment here and then sort of mutating it. It's all done in one value. And this new sort of way of doing things, switch expressions, is, funnily enough, almost identical to F#. This is the F# way of doing the same thing, where you have match number with, if it's 1, then hello, and so on and so forth. But it's basically the same code as this, just you don't need semicolons, you don't need commas, you don't need return, you don't need curly braces, and you don't need things like the public or the types. The compiler figures them out. But this is valid F#. If you copy this into your to Visual Studio, then this will just work. This is another one that expressions are useful with, which is this notion of, in C# you can ignore results. This is the only time, as far as I'm aware, that C# will complain or warn you about this. If you're in an async block and you call a function that returns a task and you don't await it, the compiler will tell you with this lovely long message, because this call is not awaited, blah, 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 consider applying await. This is nice. The compiler isn't telling you, you've got a task and you're throwing it away. Are you sure that's what you want to do? That's useful. Unfortunately, that is the only place the compiler will really tell you. So if here I have a function or a method called getString, which returns text, and I call it, the compiler won't tell me. Why are you calling this method? You're ignoring the response. But that's kind of a feature of C#, because in C#, that's not normally how we do things. You call methods, they might have void, and they'll mutate some state internally. Yeah, so it's perfectly normal in C# to do this, whereas in F#, this is a warning. This is something wrong. In F#, if we do this, you'll get a warning immediately. The result of this expression has type string and is implicitly ignored. In other words, why are you calling getString if you're ignoring the response? And this is because in F#, everything is geared towards, I call a function, it does something, and gives me the response. It doesn't mutate some internal state. So if you're doing this, you must be doing something wrong. Why are you doing that? If you want to ignore it, you have to use this ignore keyword on the right. You have to tell the compiler, I know it's returning me something, I'm not interested in it. I know better than you. Please ignore it. You will use this occasionally in F#, not often. But when you interrupt with C# code bases, you might use this quite a bit. As a good example, actually, David Fowler, who's one of the leads on ASP.NET, he's been trying F# the last few days. If you look on his Twitter feed, you will see he's been experimenting with it. And one of the things he immediately noticed was, wow, I have to use ignore quite a lot with raw ASP.NET, because the whole way it works is it's got builder patterns that return values that are kind of just discarded quite often, which is why in F# there are some wrapper libraries like Giraffe that basically work more in line with how F# expects to do things. So that's a good example. Another one is void. So in F# there is no void. A good example of how this changes. In C#, void is kind of this, how shall I put it, this strange child sitting in the corner that no one really wants to know or do anything with. You can't assign it. You can't say print my name and assign the result to this variable. You can't assign void. It's not a real thing. In F#, it is a real thing because we have something called unit instead of void. And unit is a real value. You can actually pass it around and you can do stuff with it. So I can say let result equals the result of this function, which doesn't give me back anything apart from this unit object. Why is this useful? Well, think of things like tasks. In the C# world, you have two tasks. You have task of T and you have the task, which is for the void side of things. In F# we don't have that. You just have task of T. And if you have a task that has no result, it would be task of unit. This is a task that returns you back an object that has no value in it. It has nothing of interest, but it is a value. Doing this simplifies so many things because you don't have now these two hybrids of the generic and the non-generic world. Everything has a result and everything has an input. So expressions are really important in F#. And it's worth just being aware of that. Once you spend a bit of time in F# and then you go back to C#, things feel a bit different then. You notice these things that you probably just weren't aware of in the past. I'm going to skip over this kind of stuff very briefly, this working with nulls. I think just generally, C#8 is a kind of a miraculous thing. The stuff that Jared and Mads have done with C#8 is incredible for this null, the null checking stuff. Yeah, it looks really, really difficult. I can only imagine the hoops they had to jump through to get out a solution that works. But there are some limitations they had to do with it. Things like warnings, not errors, because you can't have breaking changes. So everything with the non-nullability is warnings. Secondly, you had to put in easy escape hatches to turn off the null checking, because the nature of it means that it can't guarantee correctness, and B, there are just so many cases and corner cases within C# where it might not work, basically, or at least where you might need to tell it you know better. And the part of that is because the way C# works is it uses this thing called flow analysis, where it tries to look at your code and see how you're using it. And that means it's quite complicated, certainly more complicated than how nullability works in F#, which is quite simple. It's just using types. The C# way is very smart, but it means that it's quite complicated. There are lots of corner cases where I'm seeing people see things like, this should show up as null. Why doesn't the compiler figure it out for me? And then you've got attributes that you can put on methods in C# to tell it things like, well, if this value returns X, then Y should be null and stuff like this. It's pretty complicated. So as an example here, if I've got this nullable string called text and I assign it to a non-nullable string, I get a warning, but I can override that with this exclamation mark. So they've explicitly built into the language an extra operator to turn off the compiler checking, which tells you, you're going to need to easily do this. This is going to be a common thing to do, or at least not uncommon. In F#, this is very different. We actually have a type called option. So this is an optional string, and we're trying to assign that to a string. But in F#, this just doesn't work. There is no way around this. This is like trying to assign an int to a string. They're not compatible. They're two different types. So there is no flow analysis here. This is just, I've got an optional string. This is a string. They're different things. You can't assign them from one to another. Again, Here in C#, we've got this flow analysis. So if text is not equal to null, the compiler will magically let you work with text on this part here. But if you haven't done the null check, it will know that it's non-nullable, it's still nullable, and it will give you a warning. This is this flow analysis. In F#, it doesn't do any of that. So if I check if text is some option, the compiler does not care. It will both times say, you're not allowed to do this. You can't touch the length property. Text is an optional string. It's not a string. Yeah. So in effect, it's basically, there is no flow analysis. This is just normal types. Everything is explicit. How do we do it in F#? You use pattern matching. So you can match on text and say, if the text is some text, then we can safely unwrap it and assign the length, or it's nothing, in which case I need to give back a default length, which I'm going to give a 0. And this is just normal pattern matching that you see everywhere in in F#, except it's used here as just simple unwrapping of types. And you've got other types that are fairly similar to this, like results and things like that. It works the same way. There's nothing magical about working with optional data in in F#, in the sense that there's no custom language features, there's no custom operators, it's just library. It's really just types. So where in C# we've got, async await as this kind of specific thing for working with asynchronicity. In F# we've got this thing called computation expressions. I'm not going to talk about that or show you more about that, but it's basically a general purpose way of working with effects. So imagine if in C# you could await a nullable value, or await a lazy value, or something like that. That kind of notion is something that you can do in F#. In C# you've got void, which is this corner case. In F#, unit is like a general type. There's nothing magical about it, really. In C# you've got implicit type conversions. They're just not allowed. They don't exist in F#. And then in C# you've got like 4 operators and this flow analysis stuff and attributes. In F# it's just a type. It's just a standard type. There's nothing magical about it. It's just, it really is quite simple in that regard. So, so yeah, that's that. So I'm going to end the kind of the kind of sample here with a kind of a domain modeling question and challenge, and I'll take you through it from the C# point of view, and then I will actually finally do some coding, and you can see it. So this is the real question. It's a relatively simple one. Is how would you model this today? We've got a customer that can be contacted in one of several ways. So I've got an email, a postcode, or a telephone number, but only one can be selected at any time. So a customer can only have one contact method. And all of these methods have the ability to contact. You can send an email, you can post a letter, or you can phone the customer. How would you model this in C#? That's really the question. And I'll sort of show you a couple of different ways of doing it. And at some point, you will probably say, yes, that's how I would have done it. So the easiest way, I think, that most people would see is, well, just put properties for all of the different parts of all of these 3 onto a record or a class. So I've got a telephone, address, and then the email address. And they're all nullable. So in C#8, these would be all question marks, I guess. And then we'd have a single method called contact. And I'll check if the telephone number is null, then that must mean we want to phone them. So I'll call them. If the first line of the address is not null, then that must mean I've got the address details and I'm going to post a letter. Otherwise, it must be the email address. Yeah, and the issue with this is, of course, that, well, there's no real way of proving that, though. There's nothing stopping me leaving all of them blank, or putting in the address line 1 and the telephone number, or someone forgetting to wipe one and set them, and so on. So this works, but it's kind of, it's not in the pit of success. It's easy for someone to do the wrong thing here. So what I often see is people do things like, oh, I know, I'll add an enum onto the class. And the developer has to set that at the same time as they change the fields. Yeah, I see this all the time. And yeah, great. Of course, that means, though, you have to remember to do this correctly. If you don't, well, tough luck. You've made a mistake there. You know, you might then say, well, I know what, we'll group up these different components into separate classes. So I've now got a telephone and an address class and an email, but it's still ultimately the same thing. You've got these three properties on the class, and you're supposed to only set one at any time, but it's up to you to do that. No one is going to make, the compiler is not going to help you do that. It's your job to ensure that if you set telephone, that you really do set telephone details. If you set the address, you leave the other two blank, and you make sure you set the address details properly. And then maybe you've got some switch case over the enum where you say, you know, if it's this, then I'm going to access these details. And if you've done it wrongly, then if you're using C#8, even then you'll still get a compiler, potentially a null reference exception, or you'll have to do if checks and do something there. This is the only way that you can really do this, as far as I'm aware, in a type safe manner in C# today, which is to inherit from something called a contact method. So you have a telephone contact method, an address contact method, an email one, and on your customer, you'll have one of those contact methods. Whenever I ask this in the past, no one answers with, this is what I would do. No one says I would do this normally, because people can't be bothered with inheritance, or it's not easy to do, or it's just painful. So people tend not to do this, but this is the only way that I'm aware of that you can do this in C#. You then use polymorphism, you put a contact method on each of them, blah, blah, blah. It's painful. So I want to show you now how I would do this in F#. And so finally, after what, an hour and 10, I'm actually going to do some coding. So let me open up a new tab here. Let's open up a new file. So I'm in Visual Studio here. But you could just as easily do this in Visual Studio Code or in JetBrains Rider. They all work with F#, that's fine. So I'm going to try and do the same thing that we had before, which is effectively to model a customer. I'm just going to go through this and the contact methods and show you the sorts of way I would do it. So I'd normally start with something like a customer, and I'm just going to put in a record. So this is a record that has some fields. I'll say it's got a name, maybe, and maybe the customer has an age. And then they have something which I'm going to call a contact method. And what is a contact method? Well, don't really know at this point, so let's define it. So he said a contact method could have one of three ways of contacting the customer. So it could be the address, it could be the email, or it could be, and let's rename this to postal, or it could be telephone. And now I can get rid of those question marks, lovely. And we also had some data with them, didn't we? So we said a telephone, I'm going to put this as a number. So I'm going to say of number, which is an integer, phone number. Email was the address, which is a string. And I'm going to use a record inline here. Say postal had line 1, which is a string, line 2, which is a string, and the postcode, which is also a string. That's basically the model. That's basically all we really need. So let's see if I can actually sort of test this out. So on the right-hand side here, I've got this F# interactive, which is kind of like a scratch pad where I can test out code and see what it looks like. So I'm going to highlight the types and just send them into the interactive. So now I've compiled them, and now I'm going to try and make one. So let's say Isaac is a customer whose name is Isaac, and age is, at least for the next 3 days.
Could you increase the font size a little bit?
Ah, yeah, good.
For the
good,
YouTube.
thank you. Yeah. Is that okay?
Yeah, I think it's fine. Yeah.
Yeah, great. Thank you. Good spot. Age, which is a 40, and then you'll see the compiler's still complaining because I need to give contact method field. I haven't done that yet. So let me just save this file so I get a slightly nicer name. So contacts. There we go. Yeah. So I need to give the contact method. So how do I do that? Well, I say contact method is, and let's assume I was email. Email, isaac@compositionalit.com. That's it. And now I can sort of compile that, and now it's in the REPL. So I've got it there. And I can dot into it like I would normally. So I can say, give me the name back, give me the age, and I can explore my domain and make sure I'm happy with it, really. How would I do my contact, the actual contact method? So this is where it's probably very different from the C# point of view. In C#, you would normally try and associate, using polymorphism, the method with the behavior. Whereas in the functional world, we separate it out. So I'd say I want to contact the customer. And I'd say match the customer dot, or in fact, let's do customer.contact method with. And you'll see already now that F# type inference knows that this is a customer, because I'm using a field called contact method, and there's only one record in scope that has a field called contact method. Therefore, this must be a customer. So I'm going to do email address goes to, and let's just say printfn, or let's give it the text, emailing, and let's use some nice F#5 stuff, address. And if it's a telephone number, I'll say calling number. Ring, ring. And then the last one will be postal, which is an address. And I'll make a new line here, and I'll just say sending a letter to, and then it's going to be address dot line 1 and line 2 and postcode. The interesting thing here from a type safety point of view is in each of these branches, I can't access the other fields. I can't access the number for the telephone if I'm in the address branch. There is no number. So it's impossible for me to accidentally access a field for the other case. I can only have an email or a telephone or a postal at any one time. That's the thing that at the moment C# can't actually do that well. You can get around it with polymorphism and visitors. C#10 might solve that. But at the moment, this is kind of a weak point in the language. And then if I wanted to test it, I'll put that into my REPL, I'll compile it, and then I'll say contact Isaac. Then emailing Isaac@compositionalit. So now already I've not had to run an application, I've not had to build a website, I've just written some code, explored my domain, tested it out, and tried it a little bit, and sort of explored it. I'll do one more sort of small code demo, and then I'll jump back to the slides, and then we'll have some more QA. Let's assume we had a new requirement from the customer, which was that postal codes, or no, sorry, telephones, let's say, now needs to be differentiated based on the country that the telephone number is. So we've got a contact code as well. And we want to specify something like contact, let's call it country code. And we want to deal with two countries in particular, UK or Germany or some other country by string. How can we add that into our domain and sort of get everything working? And this is where I think the real strength of F# comes, is when we make changes to existing code. So I'm going to add on to our type. I'm going to say telephone is no longer just a number. It's a country code and a number. The times is like a tuple syntax. So it's basically both of those together. So we've just changed our model. And now you'll see that we get some issues. So we get a compiler error here. So fine, let's fix that. And let's say that's the country code. Great. Compiler's fixed, but I actually want to have a different message for UK and for Germany. I want to do a different thing. So let's say that this is the UK message. So I'm going to say, if the telephone is UK, then say this message. And straight away I get a compiler warning that says here, and let's see if I can zoom in on this. I'm going to risk it. Yep. You didn't cover all the cases. For example, you didn't cover the case for Germany. Let me go back that. So the compiler is actually telling us we've missed a specific case and given us an example. So I'm going to fix that one. So I'll say telephone Germany for some number, and then I'll say Ich rufe das an. Hallo, hallo. Still get a compiler error, but we've not handled the other case, which was the last one I got there. So let's now put that one there, and I'll say telephone, some other country with a number. Country is the string name of that, and then I'll just say something like calling country number. And the beauty of this is how you would model this now. So if I wanted to change the contact method to a telephone, it would be type telephone, and then it could be UK 1234, or it could be other, let's say Spain. This is a really, really succinct way of modeling what might be quite a complicated bit of code, but just a few lines here, and suddenly we've started to slowly build up a domain step by step. We're using the compiler to help us understand what needs to change, fix the compiler errors. Things will just work again now. So before I jump back, any questions on that kind of code? I mean, we can jump back again later on if needed, but otherwise we will just jump back to slides.
Yeah, just yeah, quick question about the inline record. Yeah, the inline record that you've. Yeah, I haven't seen it before that. Yeah.
So this is a feature of I think F# 4 point something, don't know which one, called anonymous records. So this is basically a way of saying, instead of having to formally define a record called address or postal, which would be like this, and then say that of postal, I can just do it inline like that and define it as I'm doing it. And you can do this in any part of the application. This is a very useful part of scripting. So if you want to, it's a good sort of go-between between tuples, like let name equals Isaac, comma Abraham, comma Germany, or something like that, where tuples in F# don't have much more than just these arbitrary bits of data. You can actually say, well, rather than that, let's actually turn it into an anonymous record. Name, surname, blah, blah, blah. And they have that's a nice way of slowly migrating into proper records. It's really useful in scripting and sort of exploratory data.
Yep, nice bit over here.
Cool. Okay. String interpolation is indeed new in F# 5. That was a question from Ernst. So yeah, in the previous versions of F# 4.6, you would have to use the sprintf syntax. So you would say emailing %s address. In F# 5, you can do this way. You can also do the best of both worlds. So you can put %s there that says this must be a string. So if I would put %i, which means int, I'll get a compiler error now that says address is a string. It's not an integer. They're not compatible. So you get the best.
There were a lot of jokes, right, about first feature from C# coming to F#.
Yeah, exactly. So this is yeah, this is now showing that F# is copying C# as well. Exactly. Exactly. And I think that is a good point though. That shows that the features are going in both directions. I think the biggest difference is I would call string interpolation a quality of life feature. It's not going to change how I design my code. It's something that makes it a bit nicer, but it's not going to really redesign.
It's more readable, yeah. I like that.
Whereas the other way around, C# is going through big changes at the moment. Question from YouTube: how do you structure your code in F#? Separate modules, files. What's the best practice? Yes, so in F# you can create modules. So I could say module customer methods or functions, and then put it in there. And then inside here, I can say customer methods dot. That's basically how you tend to organize code in F#. You create functions, You put similar functions together in modules. Your types will go normally in a few different files, maybe even in one file at the top called domain.fs. Your files will be a bit different to C# in the sense that in C# you have this ridiculous tradition of every class is in its own file. Well, in this, we'll actually bake into C# in .NET as 3 classes. So it doesn't make sense in F# to adhere to this. Because classes are so succinct, you'll tend to have just a few files with your domain in it, normally, a few other files with your behaviors in it, and modules, and then at the very bottom of your app, you'll have a function that calls everything and orchestrates it all together. That's normally a simplified way of how things work. Okay, let's get the old PowerPoint up again. So let's move this guy back here. Almost out of slides, thankfully. So you can do this in C# today, actually. I told a kind of a lie when I said you can't. You can do it by using pattern matching on the type. So you could make contact method and you could write a single function that switches over that value and tests the type. The problem you will get is C# will not tell you about exhaustive matching. It won't tell you if you've missed any cases out. It's also completely unidiomatic in what I'm seeing in C# today. You won't see people do this normally. People will go for the polymorphic approach or some other approach. So sort of round up, F# path to developer happiness, I think is kind of a few different sides. One is trust. You trust your code more because of things like expressions, immutability, sum types, or unions, which you saw just there, which makes you happier as a developer. It makes me happier. It makes my team happier. It makes me happier that my team are happier. You feel productive. You've got this REPL. You've got type inference. It's got this lightweight syntax. You can get stuff done quickly. You feel supported. There's a really, really good community. I've not really touched on that, but F# has got a really active community. I'll give you some links in a minute for that. It's open source and commercial. So there are companies like ourselves that offer commercial support on F#. Microsoft are obviously backing it, but it's also a lot of open source stuff and the whole Microsoft NuGet ecosystem, massive. And you've got a great platform. So, you know, .NET Core is really making strides. It's like all of these things coming together make me really happy. I see where .NET is going. I see, you know, the performance gains we're getting with .NET. It's a really good place to be. I saw one other question about Suave.io. So from Alberto saying, did you consider to try Suave.io, which is supposed to avoid the ASP.NET ignoring of a function's result? So yeah, Suave was certainly very, very popular a few years back, and it's still used happily by many, many people. There are other libraries like Giraffe and Saturn that sit on top of ASP.NET and give a very, very similar experience to Suave. So it's F# first, takes advantage of all the nice features of F#, but it's still running on top of ASP.NET. So we get all the performance boosts, you get all the nice NuGet packages for ASP.NET for security and stuff. You don't have to do that. The Azure integration is great, but we still get the F#'s first sort of experience. So it's kind of the best. That kind of is really what this is about, in a sense, that we can take this huge ecosystem, high performance, but yet still get this nice F# experience on top of it. And I would just end by saying on that part, F# went through a pattern like maybe 4 or 5 years ago where it was actively trying to avoid that. It was actively trying to avoid the kind of .NET libraries and build its own sort of platform on .NET. I think it's in a much better place now, where it's sitting on top of all these libraries like ASP.NET and using them, but still having great F# first experiences. I think that's the best of both worlds. How do I start with .NET, with F#, with .NET? If you have .NET Core, you have F#. It's bundled with .NET Core today. So if you've installed the SDK, you can literally open it up and type .NET FSI, and you've got the interactive console open there. If you haven't got .NET Core, you go to .NET, the Google .NET Core, it's the first hit, download the SDK, you've got it. Visual Studio is free for the community edition on Windows. Code is free and it's cross-platform, and it's got an extension for F#, and JetBrains Rider, which is commercial, but it's free, I think, for hobbyists or for individuals, I believe. I might be wrong there, but it's
it is. Yeah,
yep.
Right there. And if someone is interested in, for students or for hobbies, that I have licenses, so yeah, it's really nice right there.
Yeah. So you've got 3 different options there. If you've got an existing app today, how can you start using F#? Again, those blogs that I mentioned, I'll jump on the website shortly, but basically go to compositional-it.com, the blog's there and you can find it. But a few examples are create some what I call logic islands. So some simple modules that do a specific bit of code. You can reference F# from C#. So you can literally start to call it today. It will just look like static classes. You won't even notice you're calling F# most of the time. Another way is what I call vertical slices. So take one part of your app from end to end and see if you can implement that bit in F# or how far you can go. And the other way is the horizontal tier. So you could say, I'm going to do our caching layer in F#, or I'll do our data access layer in F#. Question on YouTube, what are some NuGet packages you often use in F#? Great question. So I guess it depends on what you want. Generally, the normal NuGet packages that you use in C# will just work in F#. There are a few corner cases. There are some libraries I would actively avoid using in F#, like Entity Framework. It's just so heavily OO mutation sort of oriented. It's very, very tricky to get working in a nice way in F#. That may change in the future, given that C# now has records. So that might sort of be a benefit for F#. There are loads of good testing libraries. So Ernst has mentioned one, which is FSUnit, but there are things like FSCheck and Expecto. There are some great data access libraries that are both C# and F# worthy, like Dapper if you're using SQL. RepoDB is another good one. There's on the ASP.NET side, there's things like Giraffe and Saturn that I touched on. If you're doing web development on the client, then Fable is a tool that you should really look at. And SafeStack is a kind of end-to-end library and sort of package that we work on, which is basically brings together a whole set of packages and lets you do end-to-end F# development from front to back end, and it's sort of all set up for you to start with to get going very quickly. If you are trying to use F# in your organization today, try and do it with more than just yourself. If you do it on your own, you'll end up being the weird guy in the corner that uses the language that no one else knows how to do. If you want to avoid that fate, try and do it with 1 or 2 other people. And I guess the last part is consistency. Even if you you do it 1 hour a week, you will very quickly ramp up. So that's not really that's more the challenge, is being consistent. A couple of other great questions I'm seeing here. So F# uses the BCL, or the base class library, which is great. But as far as I know, if I have a method with several parameters, you cannot pipe data into it, right? Is there a reason for this, or is it worked out? So if you're consuming a BCL method that is using what we call the tupled syntax, that's right, you can't pipe that in. But if you do need to support that piping syntax, you can basically write your own wrapper functions very, very quickly that do that for you. The second question from Alberto was, are you afraid of not finding F# developers for your company? It's a hard concern these days. I can only talk from my own experience, which is twofold. One, our team do F# and nothing but F#. We don't do C#. Our team is relatively small in the sense there's 5 of us, but we haven't really struggled massively to find F# people. Certainly on the contract market, there's plenty around there, particularly if you're willing to go remote. I would say the upskilling, if you're someone who's using C# today and you're doing those sorts of things I talked about, link, records, pattern matching, F# won't be a challenge for you. You learn the syntax, the ideas, or you've already got the ideas, you already get it. It's just basically turning that around into the standard way of working. Every single one of my hires in the team were people that were not using F# beforehand in their production applications. They were all C# devs, and they're all writing F# now. The ramp up time I find is relatively short, 2 to 4 weeks before they're more or less productive. So I would say it's not a huge issue from my point of view. It more depends on what your strategy is. Another example, I'll just give you as another example. So one of our customers recently have been writing an app in the medical sector in C#. They'd done a bit of F#. They'd gone to a training course of ours, and that was basically it. And we paired with them one of our devs for 2 weeks, and that was basically all they needed. Spent 2 weeks every day, spending 4 or 5 hours, and they're basically writing everything on their own now. So it wasn't really that difficult. It was a relatively small team, 3 devs, but you can do it. How feasible is it to consume F# from C#? This would be a way to inject F# into our code base. Yeah, absolutely. So F# is just library. So you can do file new project, F# class library, and you can then add a reference to it from a C# library. That's it. It's exactly the same way of doing it as C#, whereas you have 2 C# libraries where you can have one F# and one C#. And thanks to the magic of .NET, it will, render it as C# for you when you're working in C#. That's pretty much it. There are some corner cases, I won't deny it, but for the standard sort of things of I've got a module with a function and some records, you won't notice anything specifically difficult. How do you learn? So this kind of touches on that question. I would advise you to either, if you're doing it big time, then work with someone externally that's done it before. Get a book, hire an experienced developer on the team, one of those kind of things. Go to a local meetup. Obviously, this was written in the days before COVID earlier this year, but go to a remote meetup instead, which is great. Port an existing app. I mean, the best way, and this goes all the way back to that matrix slide I showed you before, there's only so much you will get from reading and watching and watching videos and stuff. Bash out, get Visual Studio open, write some code. Do something that, ports over a library that you've already done. Or if you've got a hobby project you want to do the next time, instead of spinning up a console app in C#, do a console app in F#. Try and do it. Just start typing stuff out and you'll find very, very quickly you get stuff. Just a few links for you. So F#org is the official home of F#. So I'll just do the older side-by-side thing here. So let's just jump down there. There we go. Slack is the official sort of F#org Slack channel where you can basically talk to people. There's all sorts of really good channels. So you've got beginners and code and stuff like that. So there's loads of stuff there. The F# Foundation has got guides on getting started, how to contribute. You can become a foundation member, which basically just means that you can get involved in the community through the foundation. There are the official forums. There's Twitter. There's loads of ways to get involved in that regard. So it's a plenty there. I'll just also do my bit of blurb. So this is our website. If you go onto compositionalit.com and then go to the blog, you'll find all sorts of articles on there about F#, including the how to get started one, which is, let's just find it quickly, how to become an adopter. So if you're someone that's enthusiastic about F#, but you're not sure how to actually get it in your company, we've got a 3-part series here with some what I think are good tips based on real world experience. Okay, good. Book, I don't have to do this because Pal already saved me the trouble earlier, so thank you, that will save some time. 2 more slides. Thank you, perfect. How to convince your boss, yeah, so this is what these articles are about, but don't go to them and say, F# is cool, it's got type inference. That is worth nothing to your boss. Talk about things like, it's going to be quicker to get it to market, I'm going to be happier, our devs are going to be happier, and importantly, and I'm not saying this from a sales point of view, really I'm not, just explain that there are companies like CIT that do offer training and support and coaching. Doesn't matter whether you need it or not. the biggest concern of many managers that you know is, what if things go wrong? Are there people we can call on for help? Just knowing that as an insurance policy is often good to have. So I would challenge you, if you do want to level up your F#, just spend 30 minutes reading up on it or something like this. Get a book, make a plan on how you want to do it, and just try Hello World. Literally just do a console app and run it. Try a simple app, port something that you already know, and then start using it. Obviously, it's a bit more effort than that, but those are the kind of steps. You know, don't go straight to the end. Start simple and build up your confidence over time. So yeah, there obviously won't be applause, but I'll accept it virtually. And yes, that's pretty much it. So any other QA, we can do it here. I'm just going to look. Any more questions here? I had a bad experience doing Cards Against Humanity. Fits better with a state language like F# instead of C# instead of F#, but it was my first try. So that's kind of the challenge with moving to a functional style, Alberto, which is you always have some state in your applications. And the easiest way that we think of it is, I will make a mutable variable, and every time something happens, I will modify that state. The functional way of doing this is slightly different, and there's plenty of articles. My book's got a whole chapter on it, but is essentially think of it as a function that says, given the current state and some action, give me back a new state. What's the new version of the world? So you could imagine that you've got a function that says something like, what's the current board state? What are the player points? What's the deck? What's the discarded cards? Do some action and then give me back a new version of that entire state. And effectively you fold over that. And that's a common pattern actually I'm seeing in the web world with things like React and Redux, where it's exactly that, or Elm, which use that exact pattern, which is basically some state which is immutable, give back a new version of it, and we will just fold over it step by step by step. So yeah, that's that one. Yep, David, since we know each other, feel free to also message me privately. And that goes for everyone here. You've got my Twitter handle, you've got my email address. I'm genuinely always happy to answer questions. We do a Friday sort of office hours where you can literally just set up a half-hour call with one of the team. If you've got any questions, we don't charge for that. That's just what we do. We're passionate about F# and about getting it out there and about people understanding it. So if you do have questions, you know, ask. If you've got any other things, I'm obviously happy to do any demos. I mean, it's gone way over time now, but yeah, if you've got any questions, then fire away.
Okay, we have more questions. I think yeah, we've got a lot of questions. Actually, we've got a lot of people in YouTube, more than expected. So it's been unexpected, but yeah, the F# community always surprised me in a good way. So that's really nice. Yeah, I had a lot of questions, but I think most of them, they were also answered, right? So yeah, okay. Probably for me, the question is, how did you get in F#? It was first that you were interested in functional, or you thought about leaving C# and going somewhere else and you found F#? How
did I get into it? Yeah, good question. Yeah. I think I went through a kind of a journey I think that many devs go through, which is I started writing C# with no real understanding of design patterns or any kind of, I was just writing, you know, my extent of knowledge was cat inherits from animal, kitten inherits from cat sort of thing. And that was basically it. I did my best, but I didn't really know what I was doing. And I was surprised I got around for like 3 years with no one realizing. I had no clue. And then I realized most other people don't know. And then I got some books on things like solid and design patterns and things like that. And that gave me some kind of framework at least to work in. And then I went through the whole TDD thing and I became a real sort of zealot of unit testing everything because it gave me a lot more confidence that what I was doing was right. But I got frustrated because there's a lot of overhead with writing tests, particularly if you write bad tests. So I wanted something that was going to help me get that same feeling of confidence but without the overhead and that time and cost of writing tests that basically no one else on the team wanted to do. And then I was working for a financial institution, and we did a rules engine. And I realized towards the end of the project that we'd basically written a kind of an immutable functional pipeline in C#. And the reason why it was basically pushing hard against the language to try and do what we were trying to do. And then I realized there was this thing called F#. It seems to do a lot of these things I want to do for free. Let's try it out. In those days, there were no really good resources. There was one book that I really looked at, which was Thomas Petracek's.
Yep.
But that was the only book, really. There was no YouTube videos. There were all very, very few. There really wasn't much about it. Nowadays, it's so much easier. Not just my book. There really are. There's 3 or 4 really good books. There are YouTube videos. There's a bigger community now. There's lots of examples on GitHub. So it was a lot easier. It took me 3 tries to get going with F#. I gave up twice, and then I finally stuck with it the 3rd time. But that was really it. It was just, it felt like a natural fit for me. I was writing stuff in Link in my company, in the company I was working at, and everyone else in the team would look at my code and like, oh, this is the weird Isaac code, because I was writing C# with like Link, but I wasn't using Link just for like select star from table. I was doing orchestration of business rules with things like select many and filters and stuff, and no one knew what I was doing. Whereas in F#, that was like the default way of working. It just felt more natural. So, yeah.
Nice.
Okay, great. I know there's a couple more questions, but I will put those. Maybe I can send them to you, David, and you can put them on the meetup for things like the links for the line of business applications and stuff like that.
Yeah.
Yeah. Great.
Okay, so yeah, I think we had a great meetup. So thank you very much. I hope I can invite you to Barcelona in the future. So
I would love to come back.
That pending.
That would be great. Okay. Thank you everyone for coming, and thanks for the great questions. And thanks again, Pau and David, for organizing this and making it possible. So yeah, hopefully see you again in the future.
Yeah, for sure. Yeah, keep in touch.
Brilliant. Thank you very much.
Bye.
See you.
Thank you.
Bye.
See you guys.